These are some more factoring techniques. Steps for factoring still do not change. First, you factor out the greatest common factor. Then you determine the number of terms and choose the appropriate method. So in the last video, we talked about the sum and difference of cubes and how to use it, but I do want to look at that sum and difference just a bit closer so that way we identify what's going on here. So in order to use this sum and difference of cubes, we do have to have a sum, which is addition, or a difference, which is a subtraction, of two cubes. So you have to know how to take cube root in order to do these problems. Again, the calculator will take cube roots of numbers very easily, and in order to get rid of a cube, you need to take the cube root for a variable. So you can only use this method when you have two cubes. Again, that's why you can only use this method with two terms. You have to have two cubes. If you only have one cube, again, you can't use it. If you have three cubes, again, you can't use it. You can only use this when you have two cubes, and luckily for cubes you can have either addition or subtraction, and you follow the appropriate formula. If you look at these formulas, they do look very, very similar. The major differences are the signs. So notice the a's are still there, the b's are still there, the a squareds, the a times b, and the b squareds. The major differences are the signs. So how do you remember which sign goes where? One easy way to remember that is what's starting off in the problem. So if you're starting off adding, in the first set of parentheses, you're going to put an adding. Again, those will be the same sign. And then in the second set of parentheses, notice the end is always addition. It might be quicker if I just type this out. Let's see if I can do that. Oops, that was not what I wanted to do. There we go. So at the end, or I guess you could say the third sign of the problem is always addition. And then if you notice, the second sign of the problem, or the first sign inside the second set of parentheses, is the opposite of what was given to you in the problem. It's true for the difference as well. So notice the first sign of the factored form is the same as the sign in the problem. The second sign in the factored form is the opposite of what was in the problem. And then the last sign is always addition. So if you can remember AB, A squared, AB, B squared, AB, A squared, AB, AB squared, then all you have to do is look at what's given in the problem to determine the sign. So it's always A, same sign, B, A squared, opposite sign, AB plus B squared. All right, so let's apply this now just to make sure we're set on it. So we want to factor 8AB cubed plus 27 a to the fourth. So first step, always look for a greatest common factor. So again, you can go through and do the prime factorization, or you can look at it individually. I'm just going to look at this individually here. So the factors of 8 are 2, 4, and 8. 2 won't go into 27 because it's not even. Neither will 4, or neither will 8. 27 is an odd number, so no even number will divide into it evenly. Again, 8 is the only factors that come out of it are 2, 4, and 8, besides 1, but 1 won't help us pull out a greatest common factor. So there's no number greatest common factor. So let's look at the variables. I do see there's an A in both of them, but there's not a B in both of them, so my greatest common factor is just an A. What's left over, I'll have 8b cubed plus 27a cubed. Oops, not squared. Oop. All right, so I have factored out my greatest common factor of a. Again, yes, it's factored, but always make sure you factor it completely. So I look at the stuff in parentheses. There are 2 terms. So there's only a few methods you can do for 2 terms. Difference of squares, difference of cubes, or sum of cubes. I do have a cube, and I have a plus sign, so this might be sum of cubes. So let's see if we can take the cube root of each of these. All right, so remember the calculator will only take cube roots of numbers. Again, if you're unfamiliar with cube roots, use the calculator for the numbers. So it's already up here from the last problem. The cube root of 8 is 2. And then the cube root of b cubed will just give us b. Next thing we need to do is cube root of 27. So to get to cube root, again, we hit math, and we choose number 4, or we can arrow down to number 4. And 27 gives us 3. And the cube root of a cubed, again, the cube root and the cube cancel out, just to leave us with a. So in our formula, since 8b cubed is the first term, that's technically our x. And since 27a cubed is my second term, I don't think they call it x. I think it's a and b, right? Yep. What am I talking? So my second term would be b. I was doing differences squares. Let's erase this. And we know that's the a. So all I have to do, put my set of parentheses. A, same sign as the problem, which is a plus. B, a squared opposite sign of the problem, AB, so I have 2b times 3a, always plus b squared, so 3a squared. But if you look at that second set of parentheses, I don't know, that doesn't look very pretty to me. So let's try to simplify that. So my first set of parentheses won't change, 2b plus 3a. That's always going to be 2b plus 3a. So I have the quantity 2b squared. So that means 2b times 2b, 2b times 2b is 4b squared. Opposite sign, 2b times 3a, 6ab, always a plus sign. And then the quantity 3a squared, that just means 3a times 3a. Anytime you have a square, you're just multiplying it by itself. 3a times 3a is 9a squared. Can you combine anything in the second set of parentheses? Hopefully you realize you can't, because there's a b squared, an a squared, and an ab. None of those are like terms. So I always say anytime there's a square term, try to factor it. This might be a little difficult to factor given the fact that there's two squared terms in them and we're dealing with two different variables. There's actually no way to factor this second polynomial since there's two different variables and two squares. So that's my factored form just for the 8b cubed plus 27a cubed. Oops, that was not what I wanted to do. There we go. But do not forget about the fact that we originally factored out a greatest common factor of a. So I know it's crazy long and crazy in detail, but the factored form of 8ab cubed plus 27a to the fourth is a times the quantity 2b plus 3a times the quantity 4b squared minus 6ab plus 9a squared.